So we're going to use the Pythagorean theorem to decide if the triangle is the right triangle or not. So 8 squared plus 15 squared, does that equal 19 squared? So this is 64, this is 225. So I'm trying to see this, what, 361, 289. Definitely doesn't equal 361. So the triangle coming off this third side is bigger than the other two triangles. So what do you think? Is it a acute triangle or obtuse triangle? It is obtuse. If you think about, excuse me, if it's perfect, then it would be 289. But to make the triangle make the square 361, it means the angle has to actually open up more. Down here, where the question mark is, to make that square get bigger. So this triangle is obtuse. So this problem here, I'm going to use A, B, and C. So this problem here, A squared plus B squared, actually ends up being less than the C squared if C is the biggest side.
So if it's lower than the hypotenuse, would it be obtuse?
So if I think about the triangle working perfect, that third square being perfect, if I make the area of the square smaller, that means I got to push the one side in, which makes the angle down in the corner and keep the All right, so in the second problem, same steps. 14 squared plus 19 squared, does that equal 220 or 25 squared? So this is 196 plus 361. Does that equal 625? That's 557. Does not equal 625. So I did my calculations correctly. Reading and my calculations. Okay, so this triangle is going to be another obtuse. So like the previous one, this angle here to be able to make this this area here bigger than the sum, that means the angle has to open up. So this is going to be an obtuse triangle. Another example of where A squared plus B squared is going to be less than the biggest area, which is C squared. Got an obtuse triangle. So the first two are obtuse. In the third problem, got 5 squared plus 12 squared. Does that equal 13 squared? So we have 25 plus 144. Does that equal 169? And the answer is yes. This one here is a right triangle. This one does work. So for right triangle, it's the Pythagorean theorem. A squared plus B squared equals C squared. We got a right triangle. Again, C is the longest side. And then the last one. You're going to have to help me on this one, 28. So 20 squared plus 21 squared, does that equal 28 squared? That's 400 plus 441. Help me out. 28 squared. 784. So this is 841. Definitely not equal to 784. So that means that this area here off the biggest side, longest side, is going to be smaller than the sum, which makes this triangle acute. So acute triangles, A squared plus B squared is going to be more than C squared, and that's going to make that third side, which we've been calling the hypotenuse, or the longest side, it's going to be smaller in area than A squared plus B squared. That's going to make it a acute triangle. So this idea of A squared plus B squared being more than or less than C squared is an idea that mathematicians kind of worked around. And what they were trying to figure out is, if I have A squared plus B squared and is less than C squared, and that's the obtuse triangle. And if I have the A squared plus B squared, and that's more than C squared, and that's the acute triangle, what they tried to figure out was for the obtuse, if this is less than c squared, that means if this is, if c squared is bigger, that means I have to add something to the c squared to make it equal, to make it work out. So a squared plus b squared plus something has to equal c squared. So if you look at my handout in that second page, I'm talking about the idea that we got to add something to get to that c squared. Same thing on the acute triangle. A squared plus b squared is more than c squared, which means you got to subtract something to make it equal c squared. And of course, if I already have a squared plus b squared equals c squared, I get that perfect right triangle. So mathematicians spend a lot of time trying to figure out what is that rule that allows me to figure out what goes here or what goes here. So that what is that something? So that I have a rule that says a squared plus b squared is going to be equal to c squared when I add in that something. So this is the rule that came up with. So in this rule, it's called the law of cosine. In that rule, hopefully you see the Pythagorean theorem. The a squared plus b squared equals the c squared. And I'm going to underline in red here. This piece right here, that's that something. That's that piece right here. And that piece right here. And actually, if I would put a c squared here, and I want to talk about that something, what does that something have to be for the right triangle? 0. So that something even is going to work for the right triangle. Just so happens that that something has to be 0 to make that right triangle. So this is the rule that came up with. If we have time, I will go through. Actually, there's a video as well. I'll go through, or at least we'll show you the video of the steps you go through algebraically to prove this theorem, this rule. But for today, we're just going to spend time using the rule to find missing sides, in the first case, or finding missing angles. So when using the rule, the angle and c squared, those are always opposite each other. So the reason I have the rule written this way, and sometimes if you look it up in the textbook, they may have it written slightly different. I like to put the angle and the c squared next to each other because they're supposed to be opposite each other in the triangle. So this problem here, I'm looking for w, which means the angle that I'm going to that's opposite w, that's the 49 degrees. So those are the two things that we're going to end the equation with. So that means that the a and the b here are going to be the 41 and the 36. Please understand that this is a non-right triangle rule, which means that a and b don't have to be the longest, and actually c doesn't have to even be the longest side, because this is a non-right triangle rule. So what's important here is that we identify the side and the angle that are opposite each other, and that's what we end the equation with. So we're going to start off with 36 squared plus the 41 squared. So it kind of starts off like the Pythagorean theorem, minus 2 times the 36 times the 41, and that's going to times the cosine of the angle, which is 49 degrees, and that's going to equal w squared. So the angle 49 and the w are opposite each other. That's what tells me I'm going to end with w. If the 49 would have been opposite the 41, for example, then we would end the equation with 41. This becomes really a calculation problem. So we're going to put all the information in the calculator to figure out what w squared is. So if you go ahead and do that. So the answer comes out to be approximately 1,040.313746. I'd recommend using the entire answer in your calculator. So to be able to find the length of w, what do we need to do to our answer? Okay, we did the square root of it. The square root of 1,040.31376. That's going to give us an approximation. So you like for all the answers to be rounded to thousands. So it comes out to be 32.254 for the length. Alright, so if you would go on to the next problem, which is the bottom of the same page, go ahead and get that set up. You can about a minute or so to set that problem up. And then we'll go through the same steps as the previous one. The first thing I gotta make sure of is that the angle and the side that you're using the end of the equation with are opposite each other. So we're using the 78-degree angle, and the side that's opposite the 78-degree angle is y. So that means we're going to end it with cosine of 78 equals y squared. So the 32 and the 42 are going to be the a and the b in this problem. So 32 squared plus 42 squared minus 2 times the 32 times the 42 cosine of the angle equals y squared. Always want to try to get that, again, that angle and the opposite side at the end of the equation. If you focus in on those two numbers, the angle and the opposite side, then the rest of it is really a substitution problem. So in your calculator, go ahead and figure out the answer to y squared would be, and then see if you can finish up the problem to figure out the answer for y. Y squared is 2,229.1333375. Just 3 3s. 133375. So y is going to be the square root of that. So hopefully you got a final answer of 47.214. We're good with that? Yes? All right. Any question on the first two problems? All right, so to continue the handout, there are like 5 additional problems I think to follow. These are on angles. 4 or 5? I can't remember. 4 more? Okay. So I'm going to give you a little bit of time to work on the 4 additional problems involving length, and then we'll come back and we'll continue our work with finding missing angles.